All right, so for P3-14, we've done this one a bunch of times over the years and never really caught the rounding error in the 30 degrees and the 25. Always just pretty much selected one or the other and haven't really analyzed what that geometry works out to. So I would usually go with the profile on the end. But the what kind of brought this on is doing the other positions. So if we draw the sketch from the front, no real advantage to drawing it from the top. And like I said, previous videos on the right view, we can go through and see what happens with our geometry. So I need to open up a sketch in metric. And we'll go into the front plane and pick the line, bring it back some distance, get our basic geometry in place, and have something that looks like that. All right, the other reason that kind of want to go this direction, let's see, we have 80 across the bottom, 15 on the side, 45 on the height. And then we have a distance of 25, an angle of 30, and so let's go with the 25 there. Our choices for the other 25 are to go from there to the endpoint to the endpoint, or if I pick the line and stay close, I'm going to get linear. If we move away, we'll get the horizontal, which we already have, and would tell us that it's a driven dimension, or ask us if we wanted to make it driven. And then the 30 basically becomes a duplicate dimension. So one of the things that you may encounter, and this is as good a place as any to introduce it, is if I pick that vertex and the line, I get a four-headed arrow. And if I pick the direction of that four-headed arrow, it's going to give me a direction. So don't think I wanted that one. Let's go, I'm going to hit escape a couple times. Let's go back to that line. There we go. So that's giving me 29.05, and if I make this dimension driven, then I have a fully defined sketch, but we have to decide which is the more critical piece of geometry. And that's not even, it may be within our tolerance zone, but that's not within our rounding error. So if it was 0.5 or above, it would round to 30 if we went to two decimal places, but 29, it's pretty much at 29 degrees. So we have to decide, is it 30 degrees or 25 degrees? Now, manufacturing this part, we know that if we take it over in the assembly and the 25 millimeters is the critical dimension, then we need to stay with the 25. But setting this up for manufacturing, 29, 29.05 somehow isn't as easy as grabbing an angle block and setting it up and being pretty close to machining that geometry. All right, so we need to analyze this in the assembly. So at this point, we can start looking for things. Let's go into the select, and I can make that dimension driven and make that dimension driving, and then we'll change it to 30. Okay, maybe 30 instead of 3, and we get 25.98. Also on the high side of a tolerance, closer to 26 than to 25. So that's kind of an issue. So what I would want to do is in our dimension text, if I were to put that as an operand, all right, so an inspection dimension or something, otherwise we need to call it out. See if I can get that to pop up the tooltip. And so it's calling it an inspection dimension that for our purposes would just denote, hey, we got to make a decision here. Is that more critical than the 25? All right, so we can identify. The other thing that I would want to do is mark this for the drawing. So not necessarily that I will import the dimensions into the drawing, but it gives it enough of a contrast that it would be identifiable. So if you were doing the opposite and everything was marked for the drawing, then you could unmark it for the drawing, I guess, and it would show up in purple. All right, so let's go ahead and extrude this out. And I'm going to go that way since that's the way I'm thinking about it, and it has a depth of 50. Okay, so box is highlighted in blue. It's ready to receive the dimension. We type in the 50, hit OK. We have our geometry. All right, so on the bottom side, let's break this up into two segments. So I want to open up a sketch, and we're going to put in the 45, or at least I believe it's 45. So they're giving us 32. So 7 and 9. So it is not a 45. So I couldn't really do a chamfer there. And for our dimensions, if I were to draw this as a triangle and then this is the rectangle, I could have this cut extrude, but I've done this as an example the other way across the top. So I want to reproduce that to where I can leave this as an open contour as long as it's connected. All right, so my dimensions come out to the 32, pretty much the whatever's left. And it picked up a midpoint, so I want to leave this dimension driving because I'm going to come over here, find the midpoint, and delete it, maybe. If it'll let me have it. Oh, I'm still in the dimension, so right click and select or escape on the keyboard. All right, and we're going to see that come back to where that, because it was on the midpoint, we now have to make it coincident to connect it. And then going back into the smart dimension, I could either pick the edge and the point, or we can grab the line and tell it that that is 7, and the vertical component is 9. All right, so the difference here is when I go to do the extruded cut, we're removing that material in the perpendicular face or in our geometry. I want it to go through all. With an open profile, you don't get the other in condition. It is blind, through all, both, and it kind of defaults to through all, both. Somewhere there is a little arrow, and right there, it is pointing down, which is the direction we want to remove. If we wanted to remove everything else, then I could flip the side to cut, and we would see that reverse, and then we can go ahead and accept. All right, so that gives me that geometry. For the next part of the sketch, the angles, that's going to be to the first segment, a flat, and then the back is actually the vertical component. And I can tell that that one's just a little bit off. So when I check it, I'm going to go horizontal. And that face is 30 degrees. So here, because we are projected into that sketch, even if I'm grabbing this leading edge, it would be the same as that edge, and it's able to solve for it. All right, and then we can go to 15, see what else we need. We have an angle of 30. So if you want to draw construction lines, you want to pick off the edge. We can build that same geometry. Just keep in mind that the shape can get kind of interesting. So I'm going to do that point and line one more time. And we'll put that in place. And they're doing opposite interiors, so I should be able to go 30, and that looks right. All right, so their 30 is on the extension lines this way, on the outside. So we'll make that work. And then I'm just going to bring in the other geometry. So instead of open, I could go ahead and extrude that. And if you want to give that a try, but I also want to reinforce the convert entity. So a select and holding down the control button, select the line. I can convert the entity. All right, and that brings those two edges into the sketch and gives me an on edge. And that will show up with any of the other converts. Now I would do this because when I go into the extrude cut, if I only wanted a partial, so it goes through all where the open profile, the open contour only gave me the choices of blind through all both. This now has an up to next component or up to surface, up to vertex, some different geometries that we can work from. All right, so that gives me my shape. I can check it pretty quick. I do have kind of that compound and interesting geometry. We'll go ahead and save this. I think I got everything in there. And for the drawing for this one, I'm going to do a multi-sheet drawing. So I want to go ahead with the rest of the models, and then we'll talk about the difference between a single sheet with one part, or having a drawing package with multiple parts. So we can go ahead and save that, and we'll be done here.